Hello everyone and welcome back. So in this video, let us now continue our discussion on sorting. And now let's learn about the second algorithm in sorting, which is the selection sort. Just like bubble sort, selection sort is another algorithm which helps us to sort our given array. Now let us try to understand that similarly the way we did about bubble sort. Let's say this time as well, we will be given a list of integers or elements, right? So 12, then we have 25, 11, 34, 90 and 22. Great. Now let us discuss about the philosophy of selection sort. As the name suggests, the very important thing is select. In selection sort, what I do is I try to select each and every element one by one. Okay, so I will be making sure that first let us write, okay, what is the output? Okay, so let's see the final output. 11, 12, 22, 25, 34 and 90. So in selection sort, what I do is I compare that, okay, 11 is here. Okay. Why is 11 here? Because it is the minimum element, right? It is the minimum element. So I will be going to each and every element and asking if it's the minimum. Okay. So in the round one, this time in the pass one, I will try to find which is the minimum element in all of my given array. We can see that it is 11. We should try that 11 should come to its right position. But before I do that, I think I will have to make sure that I don't lose this 12. So what we do is we swap them. Okay. So let me write the overall idea. In each pass, we see the array and select the minimum. Now, once you have the minimum, we swap that to the or to its right position. Okay. So in the round one or in the pass one, what is going to happen, everyone? We will see that 11 is there and 12 is there. Rest all elements, they will not be affected. But again, you will think that the overall list or array is not sorted, and you are absolutely right. But have we achieved something again this time? I believe yes, we have achieved something. Let me just write them in different color. So let us have green here and let us have 12 with this. I think what we have achieved here, everyone, is that we got one element at the right position. Okay. So just like in bubble sort, we were getting the largest element at the right position. Here I am getting the smallest element at the right position. Now in round 2, what's going to happen? Pay attention. In pass 2, I will again go through this part of the array. Now I will not take 11 because 11 already has reached to its right position. If I will try to find out the minimum of this whole array, then I will get 11 again, which doesn't make sense. This time again, I'm going to make sure that I go through each and every element which were left. So 11 is on the right position, right? We don't know about other elements. We'll find the minimum and make sure that I put it to its right position. So this time what will happen? We will have 11 here, 12 here, and then we will have 25, 34, 1 minute, 90 and 22. Now similarly, we will do the third pass. So in pass 3, we will try to find again the minimum element and we'll try to sort it now at this particular position. Like in bubble sort, we were able to get each and every element towards the last. Here I'm able to get each and every element in the starting. So I believe that I will need n minus 1 passes. Because again, if I'm able to put n minus 1 element at right places, then the last element will of course be at the right place. Okay. So pretty sure the basic idea is clear. Now let us try to visualize this again, everyone, through Hacker Earth. So let us go back here. Yeah. See, these are the elements. Okay, 64, 25, 12, 22, 11. I think we have the one second. The elements are different. Let me just add the one we talked on. So 25, 11, 34, 90, and 22. Great. So this is the example we took, everyone. Now we know that 11 is the minimum. But to find that, what I have to do, I have to go to each and every element, right? So let's go that. First, we will, for each pass, we will move left to right, looking for next largest value. Once that is found, it will be swapped into its final position. Okay, I think it is doing the opposite way, but let's see. So it is doing it in the opposite position, everyone. So let us try to find the other visualization. Just give me a minute. So let us try to find some other visualization, everyone. Just a second. Visual algo selection sort. So just to make sure that we don't get confused, so we can do the same thing using this thing which we discussed. It is just taking the Hacker Earth implementation, is just taking the maximum instead of minimum. Okay, so should be fine. Let us just select selection sort here. Let me zoom in and let us have the array defined here. Great. So let me make it 50. I think there is a limit. Should be fine. See, everyone, this is the array. I've just taken 50 instead of 90 because it supports till 50 only. Okay. So now pay attention. In this, I think it will be doing by the thing which we have discussed. Now let me click sort. Okay. So let us just make 6 here. Again, go. Let us sort. See this time. Okay. The speed is very high. 1 second. Great. So let us start from the complete start. See, 12 initially is the minimum, everyone. So 12 is the minimum. Now it is going and finding the other minimum. This now 11 is minimum, 3450. It found that 11 is minimum, so it is swapped. Okay. Now see, 11 is at the right position. It is saying that one with red is the current minimum. Okay. In the next pass, as we discussed, it is taking 25 as the minimum. And now it will go through the whole array to find out which is the minimum, which is or element which is less than the 25. So the way we start is we say that, hey, I have the minimum. Is there anyone else who is smaller than this particular element? You go through the whole array, and if you are able to find, once you are able to find the smallest one, then you just swap the same thing. A very good way to remember this, I will share after we see this definition so that you are able to always understand what selection sort is. Okay, so let me just run this first. So pay attention, everyone. We cannot make it lesser than 1x, so should be fine. This time 25, now 12 becomes the minimum, 34, 50, 22. So it will be swapped. Now again, it will take 25 as the minimum and will start. 34 is not smaller, 90, 50 is not smaller, 22. Okay, so see, the understanding is also written here. Set 25 as the current minimum, then iterate through the remaining unsorted elements. We will not be taking them to find the true minimum. Once you find the true minimum, just swap them. So, see, pay attention. Great. So this time 22 is the true minimum, swap them. Now we will take 34 as the minimum, find the true minimum, swap them. Finally, the last pass, 50 and 34, doing it. And now we have sorted 9, n minus 1 elements. The last one surely would be at the right position. Okay. So great, everyone. I hope this visualization overall also helped you a lot. Now, what you have to do is to make sure that you are able to code this algorithm as well. Okay, I want all of you to code these sorting algorithm from complete scratch, especially those who are learning it for the first time, because you will get a lots of confidence. If it is taking time, don't worry. Even when I was learning, it used to took me around half an hour to 45 minutes to properly code one algorithm. Okay, great. So let me share another example as well, which I was saying. Let's say there are multiple students like standing in a line. Okay, these are their heights. So let's say students are standing like this and they are of this height. The way I remember selection sort is that I am a teacher. I don't know. This is a new class for me. If I have to sort them out, what I will be doing, I will just shout that, hey, who is the smallest person in the whole line? This particular child will say that, hey, I am the smallest. Now, if I have to do it manually, I will go to each and every children to see that, okay, he is the smallest one. Once I found him, I'm saying that, hey, you come to the first position. You come in the very start of the line. Once it happens, the line is going to be something like this. So he's the smallest one, then larger, then the bigger one, then this, and finally this one. Now again, teacher will say that, okay, I have got the first person at the right position. That is good. Now who is the second smallest one? And you will find the second smallest is this one. Now you will say that, hey, you come to the second position. Now you will ask the person who is at the second position to go to its position, right? You cannot just ask him to go out of the line. So just another intuitive example to understand. Again, these are very helpful normally to understand, as well as when you are giving interviews. If you are able to give this examples on the spot, it is very helpful for the interviewer to understand that yes, this person has a complete knowledge. Okay, so always make sure that you understand via example and visualization. Great, everyone. So now what you have to do, you will be given an exercise, coding exercise, in which you have to now do the selection sort from scratch.